Yeah. Okay, I'd like to introduce Brendan, who will talk about using Libmraa. Big hand of applause, please.
Hi. So essentially, I want to talk to you about a little library I'm working on, which essentially lets you do user space I/O on general Linux boxes.
Sorry, need a microphone.
Oh, sorry.
And if you have questions, you can repeat them back.
Okay. And I apologize because this is my laptop because it doesn't work, so I don't know what I'm doing. But essentially, MRA is an I/O library for user space Linux with the intention to support as many boards as possible. And it lets you do the typical stuff you'd expect, which is GPIO, using GPIO libs, or any kind of weird methodology that your board uses. We basically have a bunch of hooks that let you do weird stuff. We support I2C, SPI, PWM, and UART enabling. We're not going to rewrite a UART library because there's like hundreds of them, and you can just pick your favorite one. We just make sure your UART port actually works. The aim is that there isn't really on Linux a good library that abstracts these all away. There's a bunch of stuff that exists, but there's not one that actually supports more than like 2 boards. So we're trying to basically make it easier. And this is what we support at the moment. Everything in black we actually do support properly. And in blue we have a PR open for a bunch of this stuff, which we're still kind of merging, going our way through, because it supports a bunch of boards that we don't all have, so we're trying to make sure they do all work before we push them. And we support the MIT VO core currently in a branch because our build system doesn't really understand, but we're not too sure how to build on it. But it does work. Essentially, it's pretty easy to support a new board. There's one C file. I don't know, depending on how complicated your board is, it's like an afternoon's work or a few days reading spec sheets. Most boards are pretty easy though. And the real question you're probably asking is it really that hard to actually do I/O on such a board sometimes? And the answer is in this slide, where I got people that were like, yeah, you know, you got an I2C device open, it's really easy, just like start talking to it, right? So this is what you need to do in order to start talking I2C on an Edison board, an I2C6. So that's everything you need to do before you can actually start writing to that device, and it will do something. And if you do these in any wrong order, it will screw up. And if you don't know where this order is, it's buried somewhere in a data sheet, and you can find it, it's all public, but it's not exactly very intuitive. And crazy enough, some of these operations will fail, but your device still works, so it's all good. So yeah, this is just one of the examples. So essentially, we do that for you. The idea of Libmraa is that the pin numbers that are written on your board are what you get, and it just works. You do nothing more. So if it's written 1 on your board, you ask for pin 1, and you will get pin 1, or at least we will try and make sure that's what you get. We support a bunch of APIs. I forgot I was going to do a demo first, but I'll do a demo right after this. We have a C API, which is our base API, the entire library written in C. Then we have a C++ header-only library. And then we use Swig to generate JavaScript and Python APIs with a bunch of interface files to try and make it slightly nicer to use Swig. Essentially, we use Python byte arrays and Node buffers. So we only support Node.js, it's not pure JavaScript. But essentially, you can extend this. We have like in a branch, we got like PHP working and Go. It's just a bit hard to make sure those all work. So, but if you're interested in porting more, we're very open. And we have some guy that wrote type maps definition file, so you can use the Microsoft type map stuff if you're into that. So let me try and show you how it works. If I can get out of this. Cool. So this is a tiny little board. This is the Edison board on a little breakout. And yeah, cool. That's handy. Oh, you don't have your minicom port set up, right? You don't have minicom set up, right? No, you've got yeah, you do, because it needs to disable the hardware flow control. Do you know how to do that? Can you do it? It's his laptop, not mine. I apologize. Cool. All right. Wait. So basically, really easily, Edison just runs Linux. But I mean, everything we support is Linux based. So just any Linux board and OS will do. Most of the devs on Arch, sadly enough. So if you run your Python interpreter, I like the Python API. It's much easier to test stuff on. Boom. So you just import it, and then we give you a bunch. When the library initializes, we run an init function for you as a C constructor. Basically, we try and guess what board you're on the best we can. So typically on an x86 board, that'll be using DMI, and we'll try and take your board name and a few parameters that we try and find, and then yeah, make a good guess. And on ARM, we use whatever we can find in SysFS. And basically, then we kind of give it to you back, so you can do stuff like, well, get the version of the library. You can get your. Oh, there's too much stuff on there. You can get the type of your platform, so it's just an enum, but we'll give you back your name if you really want. Bam. I mean, you can check, it's just easier. So basically, we can give you the amount of I/O you have, where your I/O is. So if I ask for an I/O pin that doesn't exist, it'll complain to me and do like, and tell me that that's an invalid I/O pin. So I can only request I/O that actually exists on my board. Essentially, what I'm going to show you is this little LCD display because it's the biggest LED I could find. Because I thought I/O library, we need to blink like something. So it's an I2C screen, and we're just going to like get the I2C bus up. So we'll ask for the I2C bus 0 or 1 even. That's another thing we do. So there's a bunch of I2C ports that you can't use from user space. So we try and guess what I2C bus you're going to use. So if you ask for some number that's completely stupid, we'll try and give you something that makes sense to us. So by default on this board, it will be I2C bus 6. Unfortunately, this breakout board uses 1.
What happens if you have a conflict with some other pin?
Oh, well, we guess for you, but if you guess at one that you're already using, you know, whatever. The concept we have for pins, GPIO pins, is we have a concept of ownership. So the first person that requests a GPIO to be open, so basically exports it, will own the pin. Now that means when they close it, we will clean up after it. You can not own the pin, and basically they'll then leave it open for you. But the entire idea of this is we use context and not like Arduino, which is basically kind of stateless. So you're expected to keep ownership of your I/O, and that's how we kind of trace who owns what. But we're not clever in a way that, you know, if you have 2 processes running, you ask for both the same I/O pins, you will conflict if you start writing to the same thing. That's just life. So then it's pretty simple, and if you voted on like I2C, I think this is right. Then we write registers, so I think it's this, and then that, and then, yeah, I did remember this by heart, so that's, and then I think I'm pretty sure now it should go some crazy color, there we go. So it is now red, so there you go, you communicate it to that, and I think we could change it again by making it purple. So essentially it's an RGB color, and for some reason this I2C device decides that when you're giving it 2 colors, it's good enough to display. So essentially you can write really simple stuff like this. It's fairly cross-platform. Now why would you want to do this from user space is the entire question. You could do this from kernel space, of course, and there's plenty of good libraries for doing that. Problem is kernel space hacking is a lot more complicated. It takes a lot more time, and if you want to do quick prototyping, it's just a massive pain. So that's kind of like the first little demo. Of course, we could do this from Node.js, C, C++. It's like you just pick whatever language you want. Oh, great. Our C API looks kind of like this. So instead of objects, we have context. So you initialize a context, and then in this case, you set a direction. Then you can write whatever you want to it. And then if you are the owner, like I said before, you will close the context, which can be a bit weird. You can just say you don't want to be the owner, and then it will just leave it open for whatever you want. We do that with an extra call in C, and then in C++ and Swig, you have like a optional parameter on your constructor.
Do you know what kind of toggle rate you can get in Hadoop?
So it's user space Linux, right? So I mean, if you're bit banging, just don't. But we have measured it because people seem to be crazily obsessed with doing this. We got to 2.6 megahertz on this. But it depends what you're trying to do, because that's like writing 0 and 1. If you then change the direction of the pin, then you have another latency, because that's done with an I2C IO expander. So it can be a lot more complicated than just giving you like a raw rate like on a micro. But if you're bit banging on Linux, you're doing it wrong. So we can do interrupts as well. So this is how you do an interrupt from Python. Essentially it's quite easy to do and works quite well. So you just define a callback function. Everything in your callback function does have to be an object, because of the weird way Python does stuff. But essentially, yeah, you just request a GPIO, you say what edge you want to set your interrupt routine on, and you just set it. Then obviously you can unset it, clean it up and stuff. So it's really pretty easy to program. It's what people expect these days, I guess, from IO stuff. That's talking about the two concepts we have, which is essentially the ownership I talked about, and we also have the ability to use IO in what we call raw mode. So I don't know if you guys know, but in Linux, IO is enumerated down from Arch NR GPIOs, which usually starts something like 256, but they recently changed to 512, which means the IO pins have like crazy numbers. Like, you know, if you get a Raspberry Pi, I think it goes from like 44 to like 126. You don't have that many IO, but that's what the kernel sees. So we have a translation map that we initialize when your board starts, which just makes that sensible and go along with whatever your connector looks like, or we think it looks like. But we can also override this behavior. You can initialize raw GPIOs if you want, and we use that internally a lot. So if you really want pin 13 to be what the kernel thinks is pin 13, we can give that to you. If you really want to open I2C2, you can do that as well. Whether you'll be able to do anything with it is completely debatable. So that's kind of what we do internally to support all these boards, and you can use it. It can be handy. And then a bunch of stuff we do is get platform type, get platform name. You don't need to call the init routine, although you should, because that makes sure your board is actually initialized. Otherwise, you don't know whether you initialized properly. The platform code is independent, or at least architecture independent. Platform config, you can query it, but you can't write to it, at least not now. And yeah, we log on syslog quite a lot, and you can change the verbosity and stuff. So usually on these platforms, we've even got systemd, so you can go check in the journal and make sure if anything's gone wrong. We've got a bunch of this stuff comes from the internals doc. We try and explain how we do stuff. One of the big questions we have is why we didn't go for an Arduino style API. And this really is because we need this context type thing. So we need to know who owns what pin, and we want to be able to run on multiple processes. The Arduino, you only run one program. You don't really care about running another one, especially in the x86 Arduino implementation. The first thing the board does is reset all its I/O when you start an Arduino sketch, which is really not what we want to do. We want to try and keep the board in the sanest state, or whatever state you've left it in. And a lot of the Arduino stuff, people copy and paste like an Arduino library, and it doesn't work because it's Linux, and you can't bit bang, and you really can't expect that when you do a sleep for 1 second, you're going to sleep for 1 second. You might not. And we kind of follow a style much closer to the embed APIs, where they have this form of context, but they're in C++, which we didn't really want. But if you're really not convinced, there's a bunch of guys that have wrapped our library to be Arduino style called Libmraa, so you're more than welcome to use that if you want an Arduino style mapping. And there's another guy that's done it for Node.js as well, Galileo IO. But the really cool thing is once we have an API that does abstracts our board away and does a bunch of this IO stuff, is we stop having to write code for this kind of display. Like, I don't know, but I don't want to know what the I2C bus address on this is. I just want to be able to use it, right? You get it in the box and it's all pretty from the manufacturer. You want to do a quick prototype. You just want to be able to use this Grove LCD RGB backlight screen, right? So what we do is we provide a bunch of extra APIs on top of Libmraa, which allow you to basically use finished products. So We call it UPM, so useful packages for Libmraa. At least that's what I pretend. So essentially, it's written in C++ and has again Python and JavaScript bindings. And so straight away, it's much easier. So you import the I2C LCD. The I2C LCD library that we have, and you can then just ask for whatever your LCD is. In this case, this one. Give it an I2C bus number, and display initializes, and then you have a nice little set color call, which you can call, which I don't know, whatever. And the display changes color, as you'd expect. But the really cool thing is this works now. If your board supports Libmraa, this will work on any board you have. So instead of having to copy and paste code or whatever, you can just take our libraries. We support something like 60 or 70, depending on how you count sensors and backlights and LCDs and stuff, and we're constantly adding way more. And the idea, you just kind of write your tiny little platform file, and you get all the sensor stuff for free. That's basically the concept. And we're trying to add more platforms, more devices, and more bindings. So we're really trying to, get people to help us out and see what you guys actually want to do. That's basically the idea. And I can quickly show you what a UPM module would look like. It's going to start from the start again, isn't it? Yeah, it's horrible. The UPM API builds individual libraries for pretty much every sensor or sensor class. We try and regroup sensors that reuse code together, but there are individual libraries. So if you want just one sensor, you just build that one sensor library for yourself, or you build the whole damn thing and you just chuck it on your board. It depends what exactly you want to do. And you can replace them, and they try and follow a fairly similar pattern, so all temperature sensors have a similar call for getting the temperature. So essentially, you can write your code and be fairly temperature sensor agnostic. Let's say you pick one sensor, you use it, then you pick another one, and whatever, it'll just work. The idea is people to quickly write code and not bother about what the hell an I2C device is. Example is a barometer sensor. So we have a really simple API. I think you can even call it without any parameters, and we'll use a default I2C bus on your device. And essentially, you can just ask for the temperature, and it'll just print it out to you. It's all in C++ for some reason, and we use the C API of Libmraa because at the time that's the only thing we had. And the reason for C++ is that we can then build Swig APIs a lot cleaner and a lot easier without duplicating even more code. But technically, you could write a C1 if you then had a Swig binding file that modified your stuff. So you can really do what you want. And we've got a bunch of links. It's a fully open source project, obviously. It's MIT license. We've taken loads of pull requests already for a bunch of stuff. So if you want to write a sensor driver or you want to support a new platform, we're more than open to it. We're just trying to support as many things as possible in an independent way. And that's basically it. So if anyone has any questions or...
Do you provide packages for most rescue things?
So we don't... do we provide packages for different types of distros? So for Debian, we're trying to. We've got like a start of where we're going to do that. At the moment, we support Yocto packages, so we build every single Git commit is auto-built into an IPK package that you can install, which is essentially a deb package. We're going to modify those so you can install them on Debian as well. We're more than open to having more. UPM is getting quite big. Libmraa is pretty small. We're going to try and push Libmraa into a bunch of different distros as well. But yeah, not quite yet. Anything else? Yeah?
Two questions. One, I tried to push for the Deviot support because most of those routers have GPIOs for LEDs. You can easily hack and remove and use the GPIO itself for whatever. And the second question, have you looked at the USB serial adapters? Because most of those USB serial adapters for the PCI or Polyfic or Cypress ones, I've tested patches, kernel patches for the driver that allows you to have two-class GPIO entries. I think managed to get 4 on but most of those popular SPI ST232 or the data adapters 2232, they with the flash driver you can have those GPIOs on your laptop. You don't need to buy another device like a Raspberry Pi to be able to play with GPIOs.
Yeah, so the first question is, do we support OpenWRT, right? And the question is yes, the VO core is a MIPS thing that runs OpenWRT. The only reason it's not quite in yet is because we use CMake and our build system we haven't quite worked out how to put the two together. But we're going to do that, and yeah, we'd love people to write like things for their routers so we can just use their router GPIOs. The second one is on USB serial adapters that you can bit bang GPIOs out of. We haven't really looked at that yet because we're more worried about supporting the I/O on the actual platform, on the embedded platforms. But actually, why not? I mean, there's no reason why we couldn't. The code that basically initializes the platform is very easy, so we could very much have a check at your USB devices and then see if you got an adapter and start using that. That's a really good idea. It'd be great for my testing, actually. I might have to do that, thanks. No, nothing else? Cool. All right, well, thank you very much.